last week, and I'll get to that sometime this week. My aim always is that I grade something within a week of its original due date. And any redos I try to get done within a week as well. Now I sort of fell off with that to a large degree through the first part of the semester. I hope to stay up to date on that stuff going forward. So if I can keep going with that. And it's funny, most semesters I get behind a certain amount, then I stay that amount behind the whole semester. I just never get caught up or never get further behind. So hopefully I'll stay current with that and have everything graded within a week. There was some comments that I made, and again, please read the comments and please ask if you're not sure what the comments mean. I don't feel obligated for spelling things out 100% because you have the opportunity to redo stuff. All right, so I want you to think about it and try to come up with an answer and talk to me about it if you're confused. I'm not saying I won't answer questions, but I want it to be a process as opposed to me saying, you got to change the line of the code to say this. I don't want to give you the answer if I'm giving credit for it. There is a couple of things I made comments and didn't deduct for that I do want to go over now, though. And one of them is when you're comparing string values. If you're comparing strings, let's say I have a variable called string s equals new string. Then somewhere down the line, I have a statement that says if s equals ABC. I saw this a few times in some of your work, and I did, and a student had an issue with it today. And I wanted to point out, why is that not the correct way to do it?
For one thing, it won't always work.
Okay. All right. You know spoilers here. So let's see if other people can tell me why that won't always work. What the problem is with that. The string is an object, right? And what does it mean when we say that two objects are equal? That they are the exact, that they point to the exact same object. Not two different objects that happen to have the same string value. All right? So if I do this, and if I say if s equals t, those are going to show up being unequal because those point to different objects in memory. All right? Doesn't matter that they both happen to have the same string value. And the same thing is true with any objects. If you created two pizzas and they were both small, thin crust with pepperoni, and you compared them, it's not looking to see if some of their attributes are equal. It's looking to see if they are literally pointing to the same object. So in this case, no, these are not the same object, and therefore it would show up as incomplete. Now, Java allows us to do something like this, sort of without creating a string object. Whenever we do something like this, it sort of creates a new string object transparent to us. So if we do this, it's comparing to see if that new object that we created equals that old object called s, and it's probably not going to be true. All right? And therefore, it's not going to behave the way that we want it to. How do we do this then? How do we compare the values of two string objects rather than comparing to see if they're the same object? We do that. We use the equals method. So we could say if S equals ABC, or in our other example, if S equals T. And you could actually write an equals method on the objects that we create. We could create an equals method for pizzas that would look to see, well, the two pizzas are equal if they have the same size, crust, and whether it has pepperoni or not. So we could write our own equals routine. For string, what equals means is that the string value contained in both of them works. This is something that makes, the fact that you can do things like this without following the normal syntax or this is sort of a weakness of Java in a way. In a true object-oriented programming language, you wouldn't be able to do that because it would force you to be consistent with the way that you declare strings, and this sort of treats strings sort of like an object, but also sort of like a primitive too. So that's not good, actually. But we have to deal with it because that's the way it is. And there's no such thing as like boxing and unboxing with strings. Remember, with boxing, we could have an int x and an integer y, and we could use them interchangeably. And it converts it to an object or a primitive as needed. There's nothing like that for strings because strings aren't primitive. Strings are only strings. So it isn't like there's a object version of string and a primitive version of string. It's just strings. All right. So as such, the kind of stuff that you get with boxing and unboxing doesn't work the same way. All right. So that was one comment that I put on other people, on a lot of people's stuff, or I think I even made that comment in general, that if you're comparing two strings, use the equals method. The other thing that I put for a lot of people is something along the lines of you could put more code in the superclass, or you could put less code in the superclass. All right, something along those lines. All right, usually I'd say you could put more code in the superclass or less code in the subclass. Keep in mind that when we create stuff that, what do I want to say here? The ideal is put as much as possible into the superclass. All right? Why? Because you have that code in just one place, and it can't go wrong. Or let me rephrase that. It could go wrong, of course. But if it's wrong, it's only wrong in one place. It's easier to make changes to. So, for example, let's think about the DVD and library materials one. There are things that have to be in the DVD class. For example, the fact that the fine is $1 a day. Whereas the fact that for books, I think it was $0.25 a day. All right, so there has to be something in the DVD class and the library book class that handles that. But some of the code could be put into the superclass. For example, calculating how long someone has a book out. That could be in the, or has a library materials out. That's the same regardless of whether you're talking about a library book or a DVD. If someone took something out on October 1st, and it's October 29th today, we can figure out how long they've had it out, regardless of if it's a book or a DVD. So that code shouldn't be in the subclasses, because that code is going to be identical for both of them. Now, calculating the fine, how many days you're allowed to have it out, those are the kinds of things that have to be in the superclass. All right? I'm sorry, in the subclass. because there's a different fine, there's a different duration, and all that stuff. So be very careful when you're designing it. I was kind of lenient on it, but be careful when you do that, if it can be pushed up to the superclass, that's a good thing to do. All right? So keep that in mind as you're designing classes. Another example is you can always call the superclasses function on something. That was relevant in the subscriptions example. In the subscriptions example, I said there was a basic subscription that was a certain amount of money. Then I said that there was a student subscription that was 75% and a premium subscription that was, I don't know, 50% more or something like that. What you can do, if I had on the basic subscription class get cost, first of all, I might make a public static final double. All right? Not public, my bad. Private static final double basic rate equals, I think we said it was $20 for the subscription. Let's look and make sure we understand what each of the words here mean. Private means that it can only be accessed within the class. So I could either make it private or I could make it protected. Static means it doesn't depend on the particular instance of the subscription. In our example, the basic rate doesn't depend on which subscription. Every basic subscription has the same rate. All right? So it could be a static variable. Final means it can't be changed. All right? Another word for this is a constant. All right? You might have seen in other programming languages as a constant. So I could have a getCost function that all it does is return basic rate. Now, on my student subscription, I could override this. But if the way that it was worded was that it was 75% of the basic rate, that implies that if the basic rate goes up, so does the student subscription rate. So what I could do is I could return, or I could do something like this, double cost equals super get cost, then say times 0.75. Then I could say return cost, like that. Okay? That way, a lot of people actually hard-coded the number 20 and multiplied it by 0.75. All right? And I didn't take off for that because, you know, whatever. This is our first exploration of creating classes that do that. But this is better because it then ties it to the basic class, which is the way the problem was defined. So we asked the super class, what is your cost? We multiply that by the percentage, and that's the cost. So that would probably be the better way to do that little snippet of coding.
I have a question for you.
Yeah.
You copied down the protected static double.
Oh, that was a mistake.
That was a mistake.
Yeah.
Okay. Would we have basic rate? I mean, I should know the answer to this, but I don't. Would we have basic rate available to us here?
We would have basic rate available to us if this was protected.
Okay. So
If this was private, we would not have it available to us.
so if we knew that the get cost was the basic rate, we could, instead of super get cost, use basic rate there?
You could. The only thing I think of is I am a fan of methods, right? Because what if, for example, that there was a basic that there was a Canadian rate that altered the basic rate, and it depended if it was, maybe there was a 10% surcharge if the country was Canada. Let's just say for instance. So is Canadian. I could write code that did this. I could do that and say, then, if that was the case, a Canadian student would have 75% more than the Canadian basic rate or whatever. So always give the potential to have code to handle that. So yeah, I would do it that way. So, and even if that wasn't there, I would still have the thing returned. I'd set that as a constant, but under get cost, I would have get cost and then call the super get cost just in case it changed. All right, other questions about this? Lab today. I need to leave early. I hope this is the last Monday in which I need to leave early. I have to take my brother to a doctor's appointment. Next Monday is our division meeting, which means I hope to leave our Java lab late. All right, so ask me as many questions as you can next Monday. All right, but I digress. All right. UIs for Java. We spent a few minutes looking at them last time, and I definitely want to spend more of a look at them and play around with them. And so on. Let's see. I think this is where we left off. Okay. Okay, we're going to look at GUI Example 1, and this is our first GUI. And All right, so let's review it. And then let's review the functionality of it so we have that in our head. And then we'll play with the code. Okay, we have a GUI. Frame opens up. We have a text, we have a label that says enter temperature in centigrade. We have a text box for it. We have a convert button. As we put a number in, click convert, it gives us our answer in a label. If we put in garbage in there, we display the exception trapping. It's always good to wrap, you know, when you think about defining exceptions, one of the reasons, you know, there's two big areas where you're going to define exceptions. One is which something else, you're accessing some other system or some other stuff that is outside of your program's controls. So for example, if we were doing database interactivity in this, and we were connecting to a database server and doing some kind of lookup, if we were calling the National Weather Service to do a temperature conversion, or something like that, anytime when our program talks to something outside of its control, that's a classic part to put exception trapping, right? Because if it's outside of your control, it could go wrong, and there's nothing you can do about it, right? We can't control, for example, if we were looking up something in a database here, if we were looking up, say, the temperature of a city, and it depended on there being a database that was running and had that. We couldn't control if that database was even up. That database could have crashed or whatever. So when we talk to something that's outside of our control, outside of our program's control, we definitely want to trap for exceptions. Now in this case, we're communicating via a user interface, right? Which is, the user is definitely something out of our control, all right? Because you don't know what the user's going to put in there. Now we could put validation code in there that said that look to see and make sure that they entered in a numeric value. So you could do that. You could catch the errors before they happen, but you definitely also should have exception trapping as well. And so in this case, if we look at this example, we have where we do our math, but we do that wrapped in a try-catch. Why? Because this should be a number. We could even put validation in there to make sure it's a number. But maybe we're wrong. Maybe our validation isn't right. Maybe our validation isn't foolproof. All right? In which case, we're going to make sure, because what that user enters into that text box is outside of our control. So we're going to put that statement could likely go wrong. Exactly, a more clever fool, exactly. So that is going to sort of catch any problem that occurred. Now notice why set text says invalid input. Because really, that's the only thing that could go wrong here, right? I mean, if C is a number, we can take 9/5 of a number and add 32 to it. That's never going to go wrong. You know, there's no divide by 0 here or anything. So if we have a valid number in C, this statement isn't going to go wrong, and this statement isn't going to go wrong. So essentially what we're trapping for is something going wrong with this statement. In other words, we can't take that string that was in that text box, parse it as a double, and store it in there. So that's why by error message, I'm catching any exception, and any exception you can dream of is going to boil down to, yeah, the input's probably invalid. All right. So anyhow, that's the exception part of this, which I'm jumping a little bit ahead. Let's back up, though. As I mentioned, there are two libraries that are important here for Java UIs that we're going to talk about. at least we're going to talk about in this class. There are swing classes and there are AWT classes. And we're inputting swing, and we're inputting everything in that library. That's all the basic components, like labels and text fields and buttons. That's the stuff that we're putting on here. So if we want to figure out how to put a radio button on our thing, what do? We look for the swing control for radio button. All right. If we want to look up how to put a drop down on here, we look for the swing control for a drop down list, and so on. All right. We have 3 controls here. We have 4 controls actually, but of 3 types. A label, which is a something that the user cannot enter text into. It's read-only on the screen, so we can display the value, but we're not allowed to enter data in there. We have a text field that is allows entry into it, and in this case, we specify 4 numbers. All right. We have a button which has a label associated with it, convert, and then finally I have a result label that has an empty string. The label for the constructor, notice it says enter temperature in centigrade. So each of these constructors does a different thing. With label, the constructor, with label and button, the constructor, if we give it a string, it puts the text either in the label or on the button. For a text field, if we put a number, that gives, that gives the size of the field. All right? So we've defined these components. We've defined them as attributes here of this class. This class, by the way, extends JFrame, which means that it has all the stuff that a JFrame does, all the built-in properties and methods that are available on a JFrame. A JFrame is a window for a Java Swing application. It says implement ActionListener and hold that thought, because we'll come back to that. Is that your question?
I was just curious if there was something for Java similar to Visual Studio that kind of automates all of it.
That's hilarious.
No?
Of course there is.
Is there?
Yeah, but we're not using it.
I didn't.
Yeah, there are IDEs that would allow you to graphically go and draw the interface. All right, but it's my opinion, you know, we're doing it old school in here. We're writing it from the ground up because I think that's the way to understand it. C#, you know, you use Visual Studio for, and you drag things around and all that. You could write C# in this way. The problem is it gets to be very complex because there's so many different classes and all that. I'm not asking you to develop masterpieces of beautiful GUIs, all right? But I do want you to spend some time studying and understanding the way GUIs are formed from the ground up, done from scratch. When you understand from scratch, then you'll use the tool even better, all right? So to answer your question, yes, of course there is. But again, we're not going to use them. I sort of deliberately made this decision for this class because there are IDEs, there are GUIs for Java. But I really think it's important to have at least one programming class that you really do it back the way your great-grandfathers wrote programs, right, in the 1800s, right? They didn't have no GUIs, right? They punched cards, you know. Too bad we don't have a punch card reader here. I'd totally teach this class using punch cards if we could, all right? But unfortunately we can't, so we'll do it this way, all right? Sometimes I even have that as a unit in this class, and we might, depending on how much time is left. One of the units might be to install Eclipse or what are some of the other ones, NetBeans or whatever, Xcode if you have a Mac or whatever, and write using that way. If you look at your C# code or like ASP.NET, those of you that are in like the 243 class, I mean, you see this. It just makes it for you when you drag and drop. It does a lot of the work for you. All right. So notice we only have one class in this example, right? First GUI. So this is our GUI and our programming logic and everything rolled into one class. All right? So since it's the only class, by definition, it has to be the main. All right? It has to have the main. So in this case, the main says, create an instance of yourself, which is interesting. I guess only in programming can you do something like that, create an instance of yourself. And you can do that because this is a static method, right? You may have wondered why that says static. You don't need an object to create, to access the static methods. So therefore, you can access the main method before that GUI object is actually created. And that's what this does. It creates a GUI object, which, of course, does what? Calls a constructor. So notice what this does. This set visible true. Do I have a set visible method in here? No. How does this work then? It's from one of the superclasses, like JFrame or one of its superclasses. All right? Likewise, set default close operation to JFrame exit on close. All that means is if we run this, if we close the window, the application comes to a halt. Okay? Again, these are things that are built into the superclass, all right, that are there. Remember, when we made this, we made this extending JFrame. So we have all the capabilities, all the attributes, and all the methods that exist on JFrame. So we do that. I create a JPanel, all right? A JPanel, think of that as being a page that we're going to put inside the frame, all right, or a picture that we're going to put inside the frame. This is a real simple GUI, right? There's only one screen. More involved GUIs could have a whole bunch of things in them. You know, think of like the FAFSA application, right? There is one frame, you know, of course it's a web page, I realize that, but if you think about it, your browser sort of frames the page and there's like a million pages you have to fill in, right? You go from the first page to the second, second to the third, third to the fourth, fourth to the fifth, and so on. In GUI applications for Java, you sort of have the same thing. That frame, you can have one frame, and you can switch the panel, you can switch the picture that's in that frame. And that's essentially what a panel is. A panel is something that we're going to put inside the frame. So we could actually have more than one screen within our GUI, and all we're doing is we're swapping the panel in the pane. So we could have a wizard, right? Brings up one frame, we keep going to the next thing. All it would be doing is swapping the panel inside the frame. So we're making a panel that we're going to put inside our frame. Our button, we're going to forget that for now too. Okay? We're going to save that action listener bit for a couple minutes here. What am I adding to the panel? I'm adding all my stuff to the panel. So I'm adding my label. This says enter temperature. I'm adding my text box for the temperature. I'm adding the button to do the calculation. Then I'm adding the results label. Then I'm going and adding that panel to the frame. That's what this says. It says, find the main content pane. Find the pane that panel is, or that frame is displaying, and add this panel to the frame. And then I'm setting the size of it. And I set it as 800 wide, 100 tall. All right? Piece of cake, right? So, What that gives us is that gives us this initial look of our frame. Our frame contains a panel. This guy's a panel. That panel contains the label, text box, button, and another label that doesn't have anything in it right now, but if we do a calculation, it has the result in it. Questions on that? What do you suppose would happen if we didn't do this? Just get a blank frame, right? Because we created the frame, we created the panel, but we never said put that panel inside the frame. So we'd get a blank frame. What do you suppose if we did this? Commenting that out. You won't get the results. Interestingly enough, you'll get results, all right? The results will be put inside that label, but that label hasn't been put anywhere on the screen. So we won't see results. So you're right, we won't get results. Because somewhere in Java's memory, there's a label that says negative 51 centigrade or Fahrenheit or whatever. All right? We just can't see it. All right? Because we never added that to the panel, which got added to the frame. What if we do this? Comment this off. I know we haven't talked about this yet, but now's the time. All right? Yes? Right. There's a button, and we can click on the button, but no one is waiting for that button click. It's no one's job, all right, to listen for that button click and to do something, because we have not assigned the action listener. What is an action listener? It's a piece of code that's responsible for handling when a certain event happens. And in this case, we're handling the event on the button, so we're handling when the button gets clicked. So if we have this here, and I commented that line out, you're going to sit there, click it to our heart's content. It makes absolutely no difference, all right? Because no one has been assigned to handle the button click event. Yes?
How is it different in the code?
Yeah, we can talk about that. Let's finish this example. We'll talk about that either now or Wednesday. Because what you're saying is I could write an app that forget the button, as I'm typing, do the conversion. Okay? We'll talk about that. All right? But let's go through this example. Let's finish this example all the way through first. And again, we'll either talk about that end of class today or next time. So it has to be someone's job to handle the events associated with that button. If it's no one's job, it's not getting done. It's the responsibility of a listener class to be able to do that. So what is the listener class in this case? This very object. All right? We're using the this pronoun. This means this object is going to contain the code to handle when the button is clicked. All right? Now, can any object handle when the button is clicked? Could I put anything in there? Could I put a pizza object in there? Have a pizza handle what happens when the button is clicked? Or a student? Or a customer? Well, maybe, maybe not. You have to be certified for handling button click events. You have to be something that is guaranteed to be able to handle a button click. You have to get your certification on that. How do you get your certification for that? By implementing the ActionListener. So any class that implements ActionListener interface can be assigned a job of handling the button click or anything else. Okay. If I take that off and I say first GUI extends JFrame, but I don't say that it implements ActionListener, I'm going to get an error when I compile. Let me clear screen because there's a lot going on here. It tells me that first GUI cannot be converted to an ActionListener. What that's saying is this class, first GUI, I don't know if it's able to be an ActionListener. It hasn't been certified as an ActionListener. It hasn't implemented the interface of ActionListener. So I could plug in any class into this statement as long as it's a valid ActionListener. What does that mean? How does something become a valid ActionListener? If it implements the ActionListener interface. All right? What does it mean again when we implement an interface? It means that there are methods defined in that interface, and whatever class implements that interface has to have those methods. All right? So in other words, not just anyone. I was sort of wrong when I said, could anyone do it? No, anyone couldn't do it unless it implements the ActionListener interface. Unless it implements the ActionListener interface. So, what does it mean to implement the ActionListener interface? Whoops. It means that it has to have the method ActionPerformed. That's the one method that exists on the ActionListener interface. So, if I change the name of that method, I'm going to get a compile error. Why do I get a compile error? Because I promised that this is an ActionListener, that this class implements the ActionListener interface. What that means is this class has to have all the methods defined in ActionListener. What are the methods defined in ActionListener? There is one. And that method is ActionPerformed. So, I say this, I'm certifying this object as a certifiable ActionListener. If I do that, I better make sure it has that method, ActionPerformed. If I do that, then I can plug in this object as a valid ActionListener. And if I do that, then I can compile it. I implement the ActionListener interface, so I can use it as the ActionListener for the button. And I implement ActionPerform, so I can implement that interface. And now the code does its thing, and the calculation occurs. So what does that mean then? When the button is clicked, it will call ActionPerformed on whoever its ActionListener is. In this case, our ActionListener is this. ActionPerformed, action event, that's information sort of about the event. sort of like an exception is information about the exception. I create a couple variables. I grab the value of the text box and convert it into a double. So I point to the text box. I get the text that's in it. I convert it to a double. I do the Fahrenheit or centigrade to Fahrenheit conversion, and then I set the label's result text to the result. Now let's try to answer the question that was asked. I'm going to make a second GUI. I want to do the calculation as I type something in. So I don't need a button anymore. So I'm going to get rid of the button. I'm going to comment out this code. No, I'm going to leave it here. I lied. So I got rid of the button, all right? And I got rid of the action listener for that button. So now when I run it, what happens? Oh. Okay, so I got to change all of them the first GUI too. Forgot to get rid of that. So I have the label in the text box, and I have my other label there, although nothing's in it. I type something in, I'm not getting the answer. What do I need to do? What do you think I need to do? Pardon me?
Press enter.
No.
You set the press of enter to the active listener.
Well, I think you're all kind of getting around the right answer. What I need to do is I got rid of my thing that is the button, which had the action associated with it, which had the action listener associated with it. So I'm going to have to associate a different action listener, all right? And I'm not going to put the listener on the button because the button isn't there anymore, right? So I need to put the listener on the text box. Now, let's Google this. I have my JText field, and I want a listener for when the text changes. So, should be something as simple as this. know why I copied that. I'm going to add an action listener, not to the button, which is no longer there, but to the text field. Let's see what that does for us. Then when I hit enter, it goes and it does it. All right. Now your question was as I was typing. That seems to be a little bit more extensive. Maybe we could talk about that next time. But essentially, we change the event associated with that. We'll pick up with this next time to look at how to make like better looking layouts and so on, and do more with this. And also to hook this up with other objects that we need to do. All right, we'll see you in lab.
I gotta imagine there's a similar method, the text change method.
There should be, yeah. I have to say,